All right. So I'm Loïc Estève. The title, you just got it. I'm L. Estève on GitHub, and I work at Probable, or sometimes some people call me Le Steve. So about me. So originally I didn't do computer science. I did particle physics. So I had no idea about computers. I hated them very dearly. But then, I didn't revolutionize particle physics because during my PhD, main achievement was to measure a cos and a sinus with an experimental error of 0.8. So basically, as you may know, like there is some strong theoretical bounds on cosinus and sinus, so the experimental didn't improve much. Then I did 3 years finance. I was doing C++. I was paid to do C++, and I was trying to do as much Python as I could because it was a lot more fun. And I got very lucky. Somehow I managed to get a temporary position at INRIA, which turned into a permanent one. And then I got paid to work on open source like 10 years, and mostly on joblib and scikit-learn. And I was involved from time to time with other projects like Dask and PyData more recently. And I moved to Probable 1 year ago. It's been fun. I mostly do the same as previously, and so that's good, with my ex-colleague from INRIA and others. Okay, so let's explain the joke to start with, to get it over with. So PyPI interface, why? So PyPI, when you look at stats, you will get these things like this for scikit-learn. It grows, and you're super happy because it shows that your package is great, right? So we will see there are many caveats with the data, and it's a bit more complicated than that, and greatness is not well defined anyway. So basically, each time I look at this data, so people show this data to say the package is great, which makes sense. But each time I looked in more details, it grew out frustration, this talk, because each time I look in more details, I found issues like this, and more issues like that, and more issues like this, and nobody actually talked about that. So I didn't find any blog post about it. So I'm like, okay, am I the only one to be aware of this? Probably not, but it's not public information at least. Everybody keeps their frustration or WTF for themselves. So ends the talk. Right, so I'm going to go through very quickly a few projects which I found useful when looking at this kind of data. Maybe some of you know most of them, but I will go through a bit. So basically, the source of truth is BigQuery data. So each time you do a request to the PyPI server, it will log something in the BigQuery data, which is public, and you can analyze it. You have you need to log in with your Google account. You have 1 terabyte quota per month, and you can run query like this. For example, this one I say, okay, which kind of installer type are used for scikit-learn in the last 28 days? So generally, I'm not very good with SQL, so LLM helped a lot, I have to say. Or you find blog posts of people that gives you a query and you tweak them. But in this case, pip is the most used installer type. Then it's 5 times less. You have UV. Then you have poetry, then you have request. So that means people are doing request.get on PyPI. So whatever they do with it, I have no idea. They download the wheel with request, and what do you do then? No idea. And then you have null, so probably people doing wget on the same PyPI URL, and they do something afterwards. And you have actually many other things like your mirror that we will talk about next. Okay. So you have ClickPy, which in my opinion is the best one right now, because you have a nice dashboard by default, like which show you per Python version, which show you per package version, and that's nice. And if you want to dig deeper, you can actually write query on this database. So this database is some kind of, as far as I understand, not a DB expert, a daily dump aggregated of the BigQuery database, but it's good enough for most things. So when you look at this data, okay, and yeah, you open an issue or two on their tracker, and they're reasonably responsive as they implemented the change. For example, at one point there was the main dashboard was a bit crap because it was saying packages that need refresh for packages that were popular but didn't have a recent release. And somebody opened an issue a year ago saying that the wording is crap, it propagates wrong incentives. I couldn't agree more. And actually, I looked because I wanted an example of bad use of metrics, and actually they updated it like 1 month ago, and now it's like stable packages, which sounds okay. Stable is good, right? And maybe one day, actually, something I wanted to do one day is you can use IBIS on this DB to actually do everything in Python, because right now most of my plots will be screenshot from the website. Okay, PyPI stats you probably know about. It's nice because you have a few things. It's maintained by PSF recently. PSF has taken over, Python Software Foundation. So it's stability guarantee. You have a few plots that are useful, like for example, per Python version, you can see there are some peaks for Python 3.10 sometime. Of course, no idea why. Yeah, the numbers are less inflated. They are more truthful, in my opinion, when you look at the number of downloads per month. Other websites, because I use only pip as an indicator and not everything. Other websites have bigger number, which make your project look better, but actually are more misleading, in my opinion. So PyPI, probably you have heard of it as well. So nice thing is you can have per version thing. So in this case, I show that the yellow one is the 1.10.2 scikit-learn, which was released 5 years ago, and it's still almost as popular as the latest release. So why we'll see next. And yeah, okay. Top PyPI package is a nice project by Hugo van Kermade, which is a CPython developer. Basically, in this case, it's a repo with a JSON. Every month is updated, and then you don't have to write SQL. Basically, you can write Python and get some idea about, like the trend months after months. And your package needs to be in the top 8,000 most popular package or something like this. So of course, if your package is new, it won't be in there. And Hugo van Kermade has many interesting blog posts about analyzing this data, which I used for this talk. Okay, let's start with the caveats. So if you go to the Python packaging video guide, where they tell you how to analyze the data, so the first thing that most people know is that when you do pip install, the first time you will download the wheel, and the second time, it will reuse it from your cache folder. So in general, on Linux, is the home cache /pip. And so basically, a normal user, like a human, let's say, when he may do a pip install many times, but actually he will download your package only once per my package version. And in scikit-learn case, if you have different Python version on different environments, you will download it per Python version. So you also have something that are called PyPI mirrors, where some company for compliance or security or God knows what, they have their own PyPI mirrors, and this PyPI mirror will download from the main PyPI index, and it will inflate your download counts. So for newish packages, not yet popular packages, that's one of the main bias. And also some wise words that sometimes metrics make us forget is that it's not particularly useful. It's not because a project has been downloaded a lot that it's good, and it's not because not been downloaded much that it's bad. So that's obvious, but somehow metrics make us forget that because we get drawn into these nice plots and numbers, and we want them to go up and blah, blah, blah. Right, so the first caveat, and that's where I'm going to take my Probable hat, which I have here. So I work at Probable. So Score has been created by Probable. I stole the joke from Matthew Rocklin, by the way, a Dask creator, which probably stole it from somebody else. So probableai.score/score, you can go right after this talk to Mary's talk about enhancing machine learning works with scores in Gaston Berger, so you will need to change room if you want to do that. It helps you create nice plots around scikit-learn models and these kind of things and metrics and everything. So originally when it started, basically I had a colleague which was saying, oh, that's great, we are more than 3,000 downloads per month, which, it made him happy. Great, I mean, I'm whole for happy people, but these numbers at the time, if you look into it, that's on the right, basically, most of them was Bandersnatch, which is mirrors, request, which is somebody doing requests for whatever reason, and then you get UV and pip, which is more, real downloads. It may not come from human, it probably come from TI automation, but at least it's real pip install thing. And then browser, and then null, browser, whoever does that, browser automation with like playwright or this kind of stuff, or human clicking many times the browser to download the, I don't know. Right, so actually if you looked a few months later, is actually the more pip downloads and UV, so it looks like a bit better. But Bandersnatch is still a significant part of the downloads. And this you can see on PyPI stats, actually that's the plot. You have the with mirror and without mirror, and you can see on some days that with mirrors is a lot more than the without mirror. So that means the pip install is only a small fraction of the downloads. And this installer type, as I mentioned, is the main discrepancy between different websites, where you won't see the same the same number as you use at PyPI or PyPI stats. That's what I found. Okay, I can remove my probable hat now. I'm a bit hot. So next is scikit-learn. So first, as I said, like when you look at downloads, you shouldn't think, oh, there is a human doing pip install on their terminal or whatever. Like, because if you look at PyPI website statistics, it's like 1 million roughly unique visitorship amounts, and the number of downloads is actually 100 million. So unless each user downloaded 100 times scikit-learn, I mean, you can ask yourself, how many times have you downloaded scikit-learn in the last month? I doubt that's real human. Also, the next thing is, if you look at the website analytics, it's mostly Windows, like 60% as Windows. If you look at the PyPI stats, OS statistics, is 95% Linux. So you know, it's not, those are not the same persons or automation tools. Okay, a different WTF is if you look at the most popular release in 2025, it's actually 1.0.2, which, you know, was a Christmas present by Guillaume Lemaitre, which is nice, but it's like from 4 years ago. So who is doing that? I mean, like, maybe we should stop developing scikit-learn and just maintain it, because apparently people care about this very old release. Maybe. And something, I looked a bit at it thanks to Hugo van Keramade's blog post, and you can actually realize that 1.0.2 was the latest release that supports Python 3.7, and Python 3.7 is used a lot on Amazon Linux too, which is a distribution that apparently is used on Amazon Linux. I'm not sure about Amazon Cloud. That's not my expertise, but basically, probably all these downloads are coming from this automation on this cloud usage using this distribution. I can skip because you have to trust me on this one. Okay, next WTF. Scikit-learn depends on joblib, right? So naively, you know, if you're into a mathematician mode, you would expect that joblib is downloading more than scikit-learn. That would make a lot of sense, right? Okay, you look and then you realize scikit-learn is downloading more than joblib. So interesting. So 2 times more, 1.2 times more joblib. Okay, so maths are wrong somehow. Or data is weird, which is sometimes, you know, something you need to consider. Okay, so here are some hypotheses. So maybe if you release more often, some people, like, I don't know, refresh their Docker image every hour just in case, and then they have no cache, and then if you release more often, you get more downloads. Who knows? Maybe people use system joblib with like your OS package manager, apt-get, because it's okay. They need any version, but scikit-learn, they need the latest version, so they pip install it. Maybe, I don't know, this one, I don't believe it, so I will skip it. But the latest hypothesis, which may be one of the reasons, is that pip backtracking. So what is pip backtracking? I don't know if you've noticed it, but sometimes you install something and then it starts installing. So there's a warning in info, actually not a warning, but it starts downloading a lot of different versions for some reason to solve the constraints. And one thing I tried is like you can have the download stat from Conda, and you can compare joblib versus scikit-learn, and actually in this case it's in the right order. So basically joblib is downloading 1.2 times more than scikit-learn, so it's the right order. So maybe it's a pip quirk that people are hitting these weird edge cases where some package wants scikit-learn less than 1.5, and some package wants scikit-learn more than 1.7, so we try different version of the package that depends on scikit-learn, basically. Exercise left to the reader, maybe UV, you would see the same thing since you have the installer type information from the PyPI data, and I'm sure you would get a more reasonable number. Okay, another historical use case, so sklearn. So you might not know, but you import sklearn, so you probably know you import sklearn, but you pip install scikit-learn, right? Which is like the difference between the import name and the project. It's historical, it's unfortunate, but that's the way it is. But for historical reason, we actually allowed pip install sklearn because like people would do that, and if it's a malicious actor that has this package name on PyPI, then he could install really bad things. So we did that, and it would just work for a while, right? But surely I had no idea until after 3 or 4 years I worked on scikit-learn, basically. But surely nobody's doing that, right? And actually, it turns out like maybe 20% of the downloads were from pip install sklearn, basically. So I was annoyed by it, and then we decided not to do it and not to do anything. And then after a while, for another reason, I was more annoyed, and I decided to do a brownout over 1 year, where basically you would get an error from time to time during this 1 year period, and at the end you would get an error all the time, basically. And then you have a environment variable to escape it, because some packages are not maintained and they will have the scikit-learn dependency forever, and this is okay, like there's nothing we can do about it. So what I did is we tried to disable the cache so that you would install scikit-learn all the time, but that broke poetry, so we reverted this, sorry for that. And then we release one new version every month somehow, roughly, so that people will get the new release and have more probability to get an error. So, and then you think, okay, I'm going to look at PyPI stats, because that seems a good way to see whether people are still installing scikit-learn. So if you look at PyPI stats, this is, so it's PyPI in this case, but the website, but you can do per version, and you can see that basically, so the 0.0, which was the one, that original one, which will work forever, is downloaded as much as the latest one, which is the 0.0 post 12, roughly. So you have variation, but roughly. And then on the bottom, you can see that all the other ones, so 0.0 post 5, post 7, post 9, whatever, they have the same rate of downloads, so that's why the line overlaps, which is not nothing, right? It's like 3,000 downloads per day. So what is doing this? Who is doing what? What? I guess it's what? What is doing this download of intermediary version that make no sense whatsoever? I don't know. Right, another thing is that Boto, so Boto is an AWS thing that has one release per day, because it's updated automatically, and then they create one release per day, so it's the most downloaded thing on PyPI. And Boto 3 depends on Boto core, and you have the same inversion where, like, the dependent is downloaded twice less than what it dependees, I guess. Or you see what I mean? Like, the Boto core should be downloaded more than Boto 3, and it's the other way around. So, and then there's no explanation why Boto core would be cached, but not Boto 3. It's easy to misinterpret this data, remember, so I didn't find the report again, but some people were saying, oh, 6 is still downloaded a lot, so that means people care about Python 2, because 6 was, for those who don't know, we're lucky to be not around at the time, was a compatibility packages between Python 2 and 3. And that's 15 years after the Python 2 end of life. And actually, if you look into it, like actually Python.util, the manager has more important things to do, and it's completely understandable as a manager myself, to change this. And so it's been like this forever. And so basically when you download pandas, it depends transitively on Python.util at one point, which depends on 6. So that's one of the like top 10 or something downloaded packages. Right. So is there some hope of differentiating like the what from the who, like automated user from real users? So there was some, from a long time I thought, okay, this is the CI doing this. CI downloads, like, you know, each time someone push to your repo, you do pip install, and you download a lot of stuff with CI, you don't necessarily have cache. That would make sense. So there is a data CI field on the Google BigQuery database, but only there. And for scikit-learn, it's only 10, so it's based on environment variable, and for scikit-learn, it's only 10–15% of the downloads. So right now, my thinking is more like cloud automation than CI, but maybe I'm wrong. Right. So summary of all I learned. So installer type is important. It's probably really influenced by cloud workflows for scikit-learn, AWS. Dependency being less downloaded than dependence. I guess for now, my best hypothesis is the big backtracking thing. Yeah. Okay, and then we get to the last version, the last portion of the talk, which is more about, have big thought about metrics. I don't like metrics in general. Maybe you could tell from previous, what I told previously, or jokes, yes. Okay, so it's going to be a really like, not very structured. So there are some wise words that, again, when we look at metrics and nice plots, we tend to forget, but you know, when a measure becomes target, it ceases to be a good measure. So it's good to remember this, and not everything that counts that be counted counts, and not everything that counts can be counted. Apparently, it's not Albert Einstein, it's somebody else. So I feel like reality is complex, so we need proxy measure. I completely get it. And then metrics help you to kind of summarize the information, but at the same time, in my opinion, sometimes they have way too much importance. And also, it forces people to play the game, basically. So an example I have is the Shanghai matrix for what are the top world universities. Even if you think it's rubbish, you have to play the game. Otherwise, you will go down in this ranking, and you know, good students will not come. So that's quite sad. So I do get it, you know, these complex proxy metrics. In my opinion, sometimes you have an opinion, you're like, okay, it's a bit light, I need something to back it up, so you find some data. And the first data you find that squares with this opinion, you stop. And then you don't dig deeper because you have the thing that you needed. I wish there was like a truth-o-meter, like in political fact-checking, like mostly true, mostly false, pants and fire. In my opinion, if you go on any kind of social network, most claims would be pants on fire. But I have to say my bullshit detector is very sensitive compared to other people. And I don't go too much on social media, I have to admit. And the problem is, if you want to do a fact-checking to correct these claims, then you will be always late and you will lose the battle, basically, sadly. So what I think is reasonably fair, like, is to use PyPI download stat to say, okay, you want to talk to grant agency, to investor, you want to show that your package is used. That seems like reasonably sensible. You want to see whether Python 3 free-threaded is adopted, and you want to look at the top downloaded packages, reasonably sensible. You want to look whether your new package is getting traction. Why not? Although, you know, I don't know. Maybe it's more complicated than this, but if it makes you happy, go for it. Who am I to judge? What I find misleading, personally, with my personal sensitivity, is comparing two packages misleading. As we said, like Jobly versus scikit-learn, there's some weird effect. To claim that, okay, we changed this, and this is why our package download is going up, I think it's completely misleading, unless you're very full of yourself. But on social media, you need to be very full of yourself, so that's the way. And in the end, I know, like, basically, I'm the old grumpy guy on the left, and people just want to know a nice plots and feel good about themselves. So it's not going to matter that much, but I tried, right? I tried a little bit. Okay, so after having looked multiple times in different contexts, there are many caveats in the PyPI download matrix, and I don't understand the reality behind it. Probably in scikit-learn case, at least, it's heavily biased by cloud workflow, and maybe, just maybe, we should refrain from book claims based on this data. And why not, you know, using proxy metrics and telling stories, but maybe you should clarify intent, like what are you trying to get at, and confidence level, okay, this is what I think, what do you think, rather than, hey, look at my package, it's so great. My package I've doubled since last time. Thanks.
Thank you for this food for thought. Do we have any question in the audience? Yeah, 2 questions over there.
Yeah, thank you for the nice talk. I had a question about educational downloadings or tutorial downloadings, because it could be a source of massive downloading if, for instance, all the students of many schools try to try Python and some packages. So is there a way to measure that or to know more about that?
So I think you can look at I don't think you can get this data like in a fine-grained fashion. The fact that I would expect the students to go to scikit-learn org website, and so that the fact that there are 100 more downloads than website visitors, I doubt this is the main explanation, but you know, it would be my feeling.
Thanks for the insightful talk. I have a question around how we can dig deeper into like package usage itself. Like, have you investigated down this line, not just looking at download stats of like specific versions, but actually how those versions or features within a newly added version that's released are used, and to gain insights around that?
So it'd be, I mean, like as a maintainer, it would be super interesting to know, like, you know, whether, okay, we added this feature, is it what made us more popular, or are actually people using this feature? I would be super interested to do this, obviously. Since even like at the coarser grain level, I don't really understand this data, I would be hesitant to go, but maybe something interesting to look at. the thing is, by default, there is some kind of growing curve, you know, like whether it's due to download to feature or whatever, it's hard to tell, basically. As I say, my bullshit detector is very sensitive, as I say, but basically, like someone who claims, okay, we added this feature in scikit-learn, and that's why you see this evolution. But I'm more happy if you have something in mind to discuss afterward, because I don't understand this data. So if someone has good insight, I will take.
That could be a data science project, I guess.
Yes, but as many data science projects, they don't get they don't reach production, right? So.
Yeah, but yeah, we do communicate those numbers to great agencies when we submit grant proposals, and
which is fair. As I said, in my mind.
And in other talks in the conference, they've been shown those graphics with curves going up. Yeah. Who else would like to ask a question? Yeah, thank you. Oh, thank you. Over there, other side.
Thanks for the talk. I was wondering, because many of the problems that you are like identifying comes from issues where logging the data. As you say, sometimes we might be tracking like the PIP mechanism for backtracking the packages. So at which point do you think is, which level do you think is possible to fix these things on the pipeline, like when we are like logging things in big queries?
So better metrics, you mean, or?
Better logging, better metrics, maybe more data to identify the ghost installing.
So I need to catch up with somebody in the conference who I had a quick chat with, who was actually more on this side, like trying to get better metrics. So I know, like, I don't know, I think I have a link there. Yeah, so Chaos is trying to get better metrics for open source. So they have a kind of practitioner guide to how to interpret metrics. So I guess these people are trying to do that, like trying to get better metrics. There's OSS Insight also, which is trying to get metrics on the repo, more like activity and issues and this kind of thing, which in my mind is interesting, but at the same time is only going to tell you part of the story, basically. But it's worth doing. Basically, maybe I'm not the one who is going to believe enough in this to do it, but I think definitely people should do it and try to come up with better metrics.
So this is more like a parallel pipeline instead of
like
I
don't think you
losing faith on fixing the main.
Yeah, I don't think you could do more on the PyPI download stat stuff unless you want to track people more, which as a maintainer, sometimes I wish I had more granular information. As a user, I would turn it off immediately as soon as I install the package. So.
All good? Oh, sorry. Yeah. Quick question, please.
Yes. Have you looked into seeing how many import statements are on GitHub, for example?
So some people did that on notebooks in the scikit-learn team. So I don't remember exactly. It was more to get an idea which object were used, like which estimator, scikit-learn estimator were used. In my mind, like most of the notebooks, and GitHub does as well. When you say used by, I guess if you have a notebook on GitHub, it might count in the used by in the GitHub information. But in my mind, there will be many kind of tutorial-like notebooks that people copy and paste it from somewhere else, and it's not clear that it's going to be very relevant. But again, like maybe we should try to do it again. In my mind, the best option for this is the website. So you go to the website, since we have the per page info. Then you can tell that some people look a lot at train test split. So it's probably one of the most looked up page on scikit-learn, or logistic regression, or this kind of stuff. And maybe in my mind, we should use this information to decide what to prioritize. So if an estimator is not looked up a lot on the website, then maybe we should say, okay, we're not going to fix any bugs on this, but we're not good at this, unfortunately. But maybe one day.
Thank you. Let's thank our speaker again.
Thank you.